as a material scientist, plastic means something very specific when we talk about it in materials terms. But culturally, we've adopted a terminology around the term plastic that isn't actually true. Assuming all plastic does not degrade is not true. Plastic is a material property.
Hello and welcome to the Conscious Design Podcast. I'm your host, Ian Peterman, and I help turn product ideas into sustainable seven-figure businesses. Join me for another episode where sustainability meets innovation and business savvy. Today, I'm really excited to have Joanna Pool. She's a sustainable materials consultant with her own firm, working on bioplastics and product innovations. And you've worked at places like HP and Philips. So now you're helping companies really find actually sustainable materials and work through all this greenwashing, misinformation things. So welcome to the show.
Thank you.
Yeah.
I'm excited to be here.
Amazing. Awesome. Before we dive into what you do now, let's take a step back. How did you get into this space? I know you worked in materials for a long time, R&D, but it's R&D is a large field, as is materials. Yeah. So how did you get to the point where you're like, I'm going to be sustainable materials. That's my thing. Let's tackle that.
Yeah. So just to kind of go back in terms of what my background is, I have a bachelor's in chemistry and a PhD in polymer science and engineering. And for a very long time, I've been interested in polymers in our products. So polymers are in your shampoo. They're in the container that make the plastic. They're the DNA in your body, and they're all around us. So I became really interested in polymers and how they influence our lives was why I got a PhD in polymer science and started at Hewlett-Packard on the product development, manufacturing, engineering side for photo paper and banner material. Worked on the inkjet side of things, but it was actually during that time when I was at HP, I started discovering bioplastics and just really understanding, they're polymers that have different end of life, polymers that can be made into plastics, different end of life than what we're familiar with traditional petrochemical polymers that are traditionally in our plastic containers that don't degrade. And so I became very interested in that and joined a startup in Vancouver, British Columbia in 2013 called Solgear Bioplastics. They've since pivoted and renamed themselves after I left to Good Natured. And I was there for a couple of years and worked a lot in product development of formulating thermoplastics for thermoformed containers, injection molded formulations. At the time, our focus was with a lot of PLA because that was probably the most readily available. Right. But I got really interested in those areas and worked a lot in a small startup. There were 10 of us at that startup. And but then I came back to the United States. I am from the States and joined Philips in 2015 and was there for about 8 years and worked on all kinds of products from whitening products to improving quality calls on the Prestige 9900 toothbrush, as well as by the end of my time at Philips, I was working on in a venture group how to bring products, toothbrushes to different markets. But I decided to take a break in 2023 and did some traveling and really got some opportunity in that 2023, 2024 to reflect on what do I really want to do when I come back to working. And I really saw that I wanted to get back into bioplastic, sustainable materials and help companies because one of the challenges with bioplastic materials is they work in the same way on the same equipment. You can injection mold them, you can thermoform them. So they are drop-in in that term. You don't need new capital equipment, but they aren't drop-in from the manufacturability. And some of the challenges that I have seen, I left that industry 10 years ago, and then I've come back and we're still having the same challenges. We're still seeing the same problems. And if anything, some of the marketing has gotten worse in terms of misleading, what I feel is misleading commentary around what are bioplastics. I've actually seen a trend away from the term bioplastics. No big deal either way. It's actually a kind of a confusing term, to be honest, in terms of how it's defined. But it made me want to help companies both with in the space of product development of bioplastics, bringing product to market, right? Some of the challenges with there's small temperature windows, there's challenges with how you injection mold it, but also in helping brands, right? What are the appropriate marketing that you can make? What are the challenges and the trade-offs that you have? Like a good example would be biodegradability is a tricky term. Your material could very well be biodegradable. There is an ASTM standard for biodegradability, which people don't like to use, but they like to claim they're biodegradable. But then there's regulation. Some states don't allow that in the state of California, and I think it's Maryland or Michigan. You can't say biodegradable. So what is the most appropriate way in helping people navigate that in terms of what resonates with their audience? Do they understand the difference between compostable, industrial compostable, biodegradable? There's all these subtleties. And I really feel for consumers because I'm an expert and sometimes I get confused. What are the claims? So, I really want to help companies make appropriate green claims so they don't confuse customers. Because when we confuse customers, we lose trust. And then we also push customers towards a lot of fear. Like there's a lot of fear mongering around chemistry in particular. I love that I ended up in both chemistry and plastic. And I'm like, everybody hates my expertise when you get out there, but we need it. So it's just, I really want to be able to help companies make appropriate claims and also help them bring new products to market, as I have a lot of experience in that area.
Labeling and claims is a massive, massive issue. I was on a panel for the Household Commercial Products Association, December 2024, and we're talking about sustainability and things, and the questions, because this was where big companies, their representatives were showing up to talk about, hey, we have what's going on, how do we address this? And the questions they were asking were all around, well, nobody trusts what we're doing. Nobody trusts these words. We're having trust issues. And so a lot of the conversation was around, how do you talk about this? Like you're saying, you can't even use some words in some states. Like those things don't match. Plus, you have had so much greenwashing for so many years on other very useful labels, but now we don't have that. That meaning has been lost because it's been abused and it doesn't have the trust. So like nobody has a good answer. And this is like Fortune 500 companies were showing up and startups, and none of them, like nobody had a solid answer. Well, probably one of the closest was someone that they were working on actual label consistency in having, there's 100 different, certifications and whatever, but how do you consolidate that into something that a consumer trusts? How do you do that?
And it's meaningful
on a tiny package too.
And meaningful.
In an inch by a quarter inch section. How are you going to do that? How are you going to do that? So it's a big problem. And I think some of the things you've mentioned, all the things you mentioned, but the one that really jumped out is like the use of materials and the meaning. The meaning of words it's a lot of work.
It is, and it's really important. The nuance. I always feel like I sometimes am like overemphasizing things, but there's things that it's important to be concise, right? And people like it's not as sexy marketing for sure sometimes with being like really deep in some of that. It doesn't come across as well, but it's hard as a material scientist when I see and like these words, and I'll use plastic for an example, mean something very specific when we talk about it in materials terms. But culturally, we've adopted a terminology around the term plastic that isn't actually true. So the challenge we have is really, how do you have that conversation with consumers so that they trust you, so that they know that what you're saying isn't just greenwashing them, but also is relevant, right? So it's a complicated layers, and I see startups, I see big companies, and actually I see a lot of more so with big companies. They tend to just step away. They're like, we're just not going to make a claim. Some of them have actually quietly walked away from some of their sustainability goals and objectives, whereas some startups are making claims that I'm like, "Ooh, that's you need a material scientist," but they to help vet some of those things. And so there's better ways. But I feel that like consumers then are just like they want to do the right thing. They really do. The ones that are really wanting these claims are really intent on doing the right thing. And we're doing a disservice when you put a product out that confuses them. It's really a disservice to their customers to confuse them because, again, going back to what we said, you build a lack of trust. And then, especially if like the FTC decides to come down, which they have on some greenwashing claims, and then people are like, well, why do I even bother? Like nothing matters. So
Right. Well, and it's so true. I love that you brought up people want to do the right thing. I was part of a group. We did a couple national studies in 2023, 24, where we were polling people to find out, and we were presenting this in front of like Congress and the Senate for circularity. And one of the things that, because a lot of people are like, oh, no, Republicans don't care about this, or right, they think there's these lines, but when you broke it down into things like, would you want recycled? Do you want to renew? Like these concepts, if you change the wording a little bit to a less politicized version, then all of a sudden you realize that like 90% of the U.S. population is very much for all of these ideas of recycling and taking care of it. Be efficient. Don't have waste. Like these things, like nobody's sitting there going, yeah, I want to waste as much as possible. Let's just burn it all for fun. Like that's not the actual consumer out there. But when we tested certain words, like even sustainability, it's been so politically charged or culturally changed in some way, where you get these weird lines where like, oh, these people hate that. These people are, but if you break it down into these more common denominator words, then you're like, oh no, they actually do want it. They just language is super important, but it's also hard, like you said, like with the word plastic, which I would like you to dive into, like let's talk about the actual meaning of plastic, because that's one of those, like, I don't even know if it would be possible to change that in a generation. It's hard to change the definition of a word quickly.
Right.
It's hard. But yeah, this is plastic. Let's talk about plastic. Let's
talk about plastic. But before we talk about plastic, let's talk about polymers, because this is where, like, I think some of the challenge sometimes can happen. So polymers are, poly just means many and mer means units, many unit chain. So I always think of like a polymer chain as little, like a chain link fence where you have lots of little pieces that go together. So when we talk about something like polyethylene, you have little ethylene units that have been shoved together, right, in a chemical reaction. And so what we see is we have feedstock. So whether it comes from oil or plant material, we also have polymers that are natural in nature, right? So DNA is a polymer. We talk about base pairs. People identify with the idea of base pairs. You have a repeating unit chain, RNA, proteins. Those are all naturally occurring polymers, which means that nature creates the polymer in its entirety. And then we have materials that you can take, nature-based, like corn, you can take sugar, and you can have a bio-based material to create the base units to make a polymer. That's another way to make a polymer. And then there's the traditional way of making polymers, which is from oil. So from oil, the whole process, that you get different types of monomer units, and you can then make polymers. I'm simplifying. There's a million other aspects, but let's just keep it as simple as that, right? So the challenge that we see is, so from these, polymers, you can then take the material and do different things with them. You can make a thermoplastic. Like a thermoplastic material is polyethylene, polypropylene, the containers that you make, right? You can make a bioplastic, which means going back to that bio-based feedstock, and you make a polymer. You make a bio-based polymer, and then you turn it into a plastic. You can also take naturally occurring polymers like starches, polyhydroxyalkanates that are already fully developed polymers in nature, and you can extract them, develop them, and turn them into a plastic. And they can all, and by plastic, the term I'm going off of, I even like re-looked at this morning, was just like, what is the origin of the term plastic? It's actually from a Greek word called plastikos, which means capable of being shaped or molded. And the reason why I kind of went back there is when we talk about plastic, what we're talking about is being able, a thermoplastic is able to be shaped or molded. In engineering, there's also a plastic region, which means it's the material's reversible. At that point, we don't need to get into that, but just focusing on the capability of being shaped or molded compared to a thermoset. Some people are familiar with epoxies. You go to the hardware store and you want to make an epoxy, people understand I've got two parts, I mix them together. I can't heat that up and make a new shape. Right. So that's a
trip. Chemical.
It's a one-way trip, right? That's a good way to think about it. Rubbers, also elastomers, tend to be a one-way trip too, meaning that like you take those big polymer chains, or think of them as spaghetti, and you cross-link them so that they can't be, again, if you heat them up, you can't change the shape. But a thermoplastic, you can change the shape with some heat. And so the challenge is we culturally say that plastic is actually a subset of this thermoplastic, and we refer to plastic as things that don't have good end of life, right? So because plastics that have poor end of life, like polyethylene, polypropylene, the major plastics that we use or have been using over the past 80 plus years, don't have an end of life that degrades. We tend to say all plastic doesn't have a good end of life. And so rather than these it's not even petrochemical based, it has to do with the chemistry of the material and the microbes in the environment of whether or not there's good end of life. So we in packaging tend to use polyethylene terephthalate, PET, your number one, polypropylene, and those don't have good end of life. There are materials that are both petrochemically based as well as bio-based that do have compostability, do have better end of life, are aqua degradable, but those are kind of in that bucket that we call bioplastics. And so, but not all bioplastics, and here's the confusing part, and again, where the language gets in that bioplastics can be made from natural materials into a plastic that aren't degradable. They can be made from natural feedstock like sugars into compostable materials. It can be also nature-based materials that degrade. It can also be petrochemical materials that degrade. This is the European bioplastics definition of it. So it's not easy. And, it's a little confusing. And I say that because you can make a bioplastic that is polyethylene. So you can take sugarcane, and there's companies out there that take sugarcane and make polyethylene. And what its benefit is it's a lower, usually you've got a lower LCA, you have improvements so why would you do that? It's you're looking for a lower LCA, but its end of life is still the same as polyethylene. You haven't changed the polymer, and that polymer is the polymer regardless. But understandably, we've tried to simplify it. We're like, plastic is bad. And I understand that, but it's like, there's nuance to it. I'm like, no, we have better plastic out there that has better end of life. But then there tends to be, even within that community who's making these more degradable bioplastics, I've seen recently just people trying to call it not plastic. I'm like, no, plastic, if it acts like plastic, it's plastic. Like, Plastic is a
mechanical quality that
it's a material property. Yeah, it's a mechanical quality. It's a quality of plastic nature. And we even I'm going to take a completely different field. We talk about neuroplasticity, and that term plastic means to be able to, we understand that term of plasticity in other spaces. And so we need to just be clear that calling things plastic in a small sense of like assuming all plastic does not degrade is not true. Plastic is a material property.
And I would say that the greenwashing part too to this is where people say bioplastic. And like what you're saying, okay, you can take sugar and you can make the base material. Doesn't matter if your end polymer never degrades.
Right.
Or doesn't degrade nicely or degrades into something that's like it always, that's still bad. Whether
yeah.
It doesn't matter if it grew from corn, it's still turned into a thing.
Well, I mean, there might be, you might have reduced the greenhouse gas, but
Right. But if we're talking about end of life, which most people
are focused on
the process, right? But most people don't think about how it's made. They think about what does it look like when they're done with it? Like, what does it look like when I'm going to throw it away? And what does it look like if I throw it away and I wait 100 years?
Right.
Does it still look the same?
Right.
Did it leach off things that we don't want leaching? Like that, we kind of ignore, like not everyone. You and I both know that it goes into the material process.
Right.
But the consumer the consumer doesn't interact with that portion of it. Like it's good. Yes, we should be tracking that. We should be improving that. Obviously, I'm not saying we should just use oil as the base for everything. That's not, not what I'm saying. But if we turn it into the same end result, we've only solved half the problem. Mm-hmm. We have not actually solved. And I've seen lots of cases where we may not actually want something that degrades the same way because there is a specific use. Mm-hmm. I think it's one of those things where, at least my theory, is we figured out how to make cool plastic material. Mm-hmm. And then we did the very human thing of going, I'm going to use it for everything. And then we immediately just used it for every single thing that we could possibly, like, we used to make that out of wood. Never mind. Plastic. We can do it with this. We can do it. And we didn't really think through the end of life. And I think that's why culturally we are like, oh, plastic's bad, because we never really sat down and were like, well, let's categorize based on like, well, you're talking end of life. Mm-hmm. How do we act like, rather than worrying about plastic term, it's, well, does it, and we can get into this as well. There's composting, and then there's biodegradable, and then there's different kinds of compost. There's like throw it in the dirt. But then I've talked to people about this. If you throw, even if you have, things that are natural, like fruits, like if you throw a banana peel in the Sahara, it will not degrade as well or properly as it will where it grows, because the microbes don't exist in that region to eat what's left over from the fruit. There's a whole ecosystem, even regionally, that kind of impacts how well something biodegrades or composts.
Right. And even in terms of, should we be adding those things? Because recently I've cut a few headlines have come, although this has been going on for years. We've made a microbe that degrades plastic petrochemically, the traditional kind that doesn't degrade. And now we're going to release it into the water. And I'm like, boats are made out of plastic, right? Like, we don't, did you specify that they can only eat polyethylene? And are we sure that the holes on all boats, I'm not a boat expert, but it's just like, we are always, and it's a great innovation about humans. We are excited about innovation, but we also do a lot of innovation that has unintended consequences. And we really need to think through, what are those unintended consequences? And it's great that we want to take care of, and we need to find solutions. You may say we shouldn't find a solution for that massive floating plastic garbage barge. Don't get me wrong. We have a problem. I readily admit we have a problem and we need to fix it. But how do we do that in a way that doesn't disturb the ecosystem? Or to your point of like, how do we introduce things that are part of the ecosystem that will clean up things in an appropriate way, right?
back to kind of this not planning thing. I feel like sometimes as humans, we like to like, oh, we found the solution. And then we don't think about the fact that it just created 3 new problems. And there's always the chance that one of those is actually worse than the original problem. And it's kind of this, it's a symptom treatment system, which can work, but it can also cause other problems.
Right.
Unintended consequences to things. So it's hard too, especially when we have this. I feel there's a feeling of urgency to things too, of where we go, oh, we got to fix this now, and then we go do the quick fix, and that, I don't know, anybody that's ever tried to fix anything in their house will probably tell you the quick fix does not always work.
That duct tape doesn't stick forever.
Exactly. Hey, it's your host, Ian. I'm really glad you're enjoying this episode. I absolutely love highlighting amazing brands and founders for the awesome things they are doing. I've helped hundreds of entrepreneurs and businesses like yours turn their boldest ideas into powerful, purpose-driven brands. So if you're serious about building a brand people love, like our guests and clients do, and one that you're proud to stand behind, I invite you to dive a bit deeper with our book, Conscious Design. Inside, you'll discover the exact framework and steps we use to help entrepreneurs like you turn purpose into a powerful, impact-driven brand. A brand that stands out, attracts loyal customers, and drives sustainable growth with social and environmental responsibility woven into its DNA. Grab your copy today. You can find it on our website, consciousdesignhouse.com, or just find the link below in the show notes. Enjoy the rest of the episode, and don't forget to like, subscribe, and share. So plastics, you obviously know a lot about plastics, polymers, all those kinds of things. How would you categorize end of life? Like what? Let's talk about end of life. Because there's, and this is one that even I sometimes get a little confused on, and I have to explain or I have to go look at it again and talk to our clients about, oh, you want something biodegradable. What kind of biodegradable? How? So in all of that you've done, do you know of, or have you thought of a way, or is there a way that's a little bit easier to understand to actually help to categorize these materials as you're picking one, right? Even if you're a company or a designer, you want a certain result, you're like, yeah, I want it to actually, what we think of composting, as in like throw it in the backyard, or how can we categorize those materials in a smarter way?
I mean, I think it's challenging because now you're talking about municipal waste and the challenges we have. I mean, we have challenges, even around recycling, right? In general, in terms of capabilities. And some recycling, I want to be also clear, some recycling like polyethylene terephthalate, your number one, your Coke bottles, all that tends to get actually well recycled if it gets into the stream, right? It's 2 through 6. And 7 is just the other category. But 2 through 6, we know what they are, but they don't get recycled in general. 2s and 4s are polyethylenes a little bit, depending, but that bread bag, the film, polyethylene film, no, it's difficult to recycle. Polypropylene, I recently read something, there's only one polypropylene recycler in the United States. And the FTC even went after Keurig Dr. Pepper around claims around recyclability with their polypropylene pods. And this was a couple of years ago. I don't know what has changed. And so is that still the case? Polypropylene, I think, is a good example. We use it a lot in food contact materials. But it's so challenging to do this category because you can't talk about end of life without talking about municipal waste, right? So I live in Seattle. They accept many types of industrial compostable plastic. My compost, I can take a compostable bag, put my compost in it, and put it in my compost bin, and every week they pick it up. But I'm a huge minority, right? So some places that pick up compost won't pick up anything like compostable plastic, but they will pick up compost, right? So is the gold standard something that can be home composted so that you always have control over it, right? And so there's only a few. There are polymers that will home compost if they're the right thickness under the right conditions. Are plastics that do meet those requirements, and we do see that with polyhydroxyalkanates. I'm starting to see some formulations, people trying to take PLAs and find ways to home compost them, because traditionally PLAs need industrial composting for the higher heat. I know that some of the formulations coming out of the seaweed area, which is a lot of alginate and starch, have the potential to be home compostable. I've also seen even petrochemical based compostable plastics, your PBTs, your PBATs, PCLs, those also can be, again, bigger challenge is cost. When you're replacing a film, which is a lot of where you see this is in films, plastic films, you're talking about pennies on the pound, and people understandably have challenges with replacing that when you're talking about something costs 2 pennies versus 5 pennies, right? That's a significant increase, right? It's a big jump. Doesn't sound like it, but it is a big jump. So when we talk about end of life, it's very hard. Like, we also need to work on that, getting composters on board. How do we get composters on board with compostable plastic? How do we get regulations in place to also regulate those compostable plastics? Like, if you look at some of the legislation coming out from California around compostable plastics and some of the requirements, you can infer they've had trouble. Like, the way the legislation is written, I've inferred like they've had trouble with compostable plastics. So they're trying to do that. So the challenge is there's no silver bullet. And also, we use plastic for so many things. When you say end of life, I say end of life of what? A food contact material that can be home composted. That makes the most sense, right? Like, I feel like my bias is like all food contact material should be compostable, because it's so easy. And actually, things that can be recycled recyclers get in trouble because things aren't clean enough, right?
Yeah, the food contact ruins.
Yeah, no, like you need to
makes it harder.
Right. So I feel like that's a very good marrying of, food contact packaging should be compostable, home compostable, industrial compostable, right? But then other things, it gets more complicated, right? Because you start talking about how are you going to pick that stuff up? I mean, in an ideal world, everything would be home compostable and degradable if it got out into the environment. Polyhydroxyalkanates probably are the closest ones that have that potential. Some of the starch-based ones as well. I haven't seen the data on some of them, but I think there's so many new materials that are out there. There's even some TPUs, thermoplastic urethanes, that people are looking at in terms of they're more focused on how not to make microplastics, or that like the microplastics that come out go back to the environment, they get eaten by the environment. So I don't know it's a great question. And I'm kind of rambling on this because it's just like, what does it mean to be end of life? Because some of it is so also dependent on where you live, right?
Right. Yeah.
So end of life for who? For whom?
Yeah, I figured we wouldn't solve it. And then
we're not going to solve it.
It's, I think that's what you brought up is a really good point of end of life to who and what is it doing? And I think, like, I love the pointing out of, well, food items, because you typically too, like, one of the things that people are struggling with is shelf life of a material. And with food, you already have a shelf life. The food will go bad at us. Like, you only have to keep the material lasting as long as food lasts, which is not that hard to beat food. It doesn't last forever. So being able to, marrying, I think that goes back to kind of the original, we just used it for everything and didn't think about the application as much. And it's one of those, like, the plastic stint that goes in you want that to last at least X, right? It's got to do its job. But the thing that holds your bananas or your apple container, it does not need it. It also has a set lifespan, but it's a way different. And so looking at really more the use case, and that's where I see a lot more of these home compostable materials. People, I think, have finally figured out that there's that sweet spot with food items. And I've been, especially the seaweed world, they're mostly focused on food-based, food packaging, food wrapping, food carrying kind of materials. And I think part of that also alleviates the need to go, well, this got to last 5 years. Or that's that, right? You don't have to make it last that long, and you can allow it to be home compostable and not stress about that. I wanted to circle back. You talked about a couple times, you mentioned petroleum-based plastics being able to decompose. People also associate all oil-based products as basically forever materials. So I would love for you to let's expand on that. How, because I think there's a little breaking of mind a little bit on like how does that work? And my guess is it's based on which polymer it actually is. So maybe you could talk about like how can that actually happen in a way that doesn't, because it's one of those, it's a pollution. So how can
if it's oil, it's not going to degrade.
Go back. They think of
it'll never degrade. Like that is, I think that's a good point to point out. Culturally, that's what we think, right? But as a chemist, I'm always like, but chemists I love chemistry innovation because I'm like, give chemists enough time, they'll figure out how to make whatever you need to be made from. Because at the end of the day, we always have to go back to the building blocks, right? So I'm going to go back to the building blocks I touched on a little bit earlier. To remember that we started making, the plastic industry came out of the innovation from the oil industry, where you can make these little monomers from oil. But you can make monomers from other things. Again, coming back to the ingenuity of chemists, they can make the same monomer. I'm going to use the example of polyethylene, and then I'll get into degradability. So polyethylene can be made from oil. You can also make polyethylene. So what you're trying to do with polyethylene is you're trying to make an ethylene unit, and then you'll have a process to polymerize it and turn it into the polymer, and then you turn it into the plastic, right? Going back to what we talked about, polymers are just big chains. So polyethylene is a repeating unit. It's an ethylene repeating unit. And your feedstock, where you get those little ethylene units, could be from oil, can also make it from sugarcane, right? Or, I mean, I shouldn't even say from sugarcane. It's a sugar-derived process, and sugar can come from, right now, the company that's making it is using sugarcane because it's out of Brazil, and sugarcane's plentiful. I'm sure you could make it, again, those chemists can probably make sugar from those same units from corn, any kind of sugar-based, right? So again, coming back to like, you're trying to make an ethylene unit. And once you get those ethylene units, you can polymerize it however we've traditionally polymerized polyethylene. So then it's like that first feedstock goes into it. So, and then its end of life is dictated by the microbes in the environment and the type of chemistry, right? Polyethylene is quite hydrophobic. There aren't microbes that eat it up in the environment, and therefore it doesn't have an end of life that is suitable. PBS, polybutyl succinate, and PBAT, polycaprolactone, those are a subset of petrochemical. They're made from petrochemicals, and as of right now, to my knowledge, no chemists have come in and figured out how to make feedstock from bio-based materials. I know there's research in that because, again, it comes back to that logic of if it degrades, therefore it should be from a bio-based source, and that's not always the truth. But it comes back to the chemistry of those materials, and the chemistry combined with the microbes in the environment enable them to be chopped up, right? And so even natural rubber compared to synthetic rubber has a different like chemistry, which can be degraded. That one's a little bit trickier, but because the degradation time, it's not really compostable, and the degradation time is longer than that. But you always have to remember, what is the chemistry? What are the microbes in the environment? To your point, a banana peel is not going to degrade in the Sahara because the microbes available that could do the degradation aren't available. So again, it's always like, where are we putting it? Are we just putting it in the ground and it's dry? And are we composting it appropriately? But petrochemical material that can be composted, again, it just comes down to that chemistry. So polyethylene can be made from a bio-based material or from oil, but because of the chemistry, it's not degradable. Whereas PBS, PBAT, PCL, I'm sure there's other ones, those have the right chemistry that the microbes that are available out there in the composter will chew them up. And so we have to think about the chemistry and the microbes in the environment of whether something will degrade.
So, as a hypothetical, then, if we kind of reverse engineered, instead of starting with the polymer and hoping that we start with the microbes, go, oh, this microbe, I don't even know, but maybe there's one that actually lives everywhere that we can find, or regionally based, but go, hey, this region, there's enough of this microbe in the soils that, hey, if we make a polymer that this one eats, we produce this, it could exist in this region, get thrown in. And yeah, we have to make another polymer for South America. We have to make another polymer for different regions. That would be a way to basically ensure, yeah, it can be degraded. You can guarantee it'll degrade because you know that this will eat it, basically.
Right. And I'm not a enzymatic, I'm not a microbe specialist, microbiologist. But I also, I've come across some writing around the fact that like polyhydroxyalkanates are made by nature. So the polymer is in existence in its entirety in nature versus, okay, I'm going to go back to the polyethylene example. Somebody with polyethylene, you take a bio-based stock and then you make the polymer. Nature actually makes the polyhydroxyalkanates. And I've seen some commentary that because of that, there are more microbes available. I don't, so is polyhydroxyalkanate that I've seen has a lot of ability to degrade in marine environments just in so whether that helps that, I don't know. I would love, that's a good question for a microbiologist and somebody who's
listening,
enzymatic specialist. Yeah, no, would love to. Yeah. So tell us, more. So could we go backwards? Like the microbes that do degrade things, what can we learn about those? I think that's a great way to think about it is we talk about end of life. What is in our environment? Because one of the challenges, even with marine degradability, is you've got salt water and it's not actually that warm where we see some of this stuff. Right. So like heat helps helps microbes do their job, but salt water doesn't. So it's not the most, not that things don't grow there, not that microbes don't live there, but I think that's a good point. Like, what are the microbes that live in salt water? If our goal is like to avoid pollution in our oceans, then I think that's a good approach. How do we backwards innovate? But the challenge is, do we know enough to be able to do that backwards?
I don't know.
I mean,
the oceans, I think I still read that we still know more about like Mars than we know about
than we do the ocean.
I would say we need some more research.
Fair enough. Yeah. So no, I mean, I love innovation and I love like what ideas people can come up with. And that's an interesting way to also look at things. Like, how do we think about our problems in terms of end of life? But end of life is also like, what are we talking about? We also have a challenge with our garbage collection system, and that needs some work. And so
yes,
we don't have if we had an ideal like process right now and we just needed to fit into that, but our process isn't that great right now.
Yeah, collection, garbage collection it would be considered reverse supply chain, and it's one of those things that everybody runs away from. Like it is it is the rare company and person that's deciding to really tackle that because it's so hard.
It's hard.
Way harder to go collect from a bunch of places and bring it to one than to sending out's easy relatively.
Well, and then collect it and bring it to one, and then what?
Yeah, and then what? What do you?
And then what?
Can you
Like
handle it? Can you
how do
use it?
we
Sort
sort
it?
it? Sort it is like one of the bigger ones. So like how do we sort it? And so much, and people don't talk about this enough. So much of our sortation requires people to go in and do the actual sorting, right? We have some processes that can evaluate with UV vis on like what the different materials are, but at the end of the day, they're used, but a lot of things are still done very manually. And I think we sometimes don't acknowledge that
And
some
nobody
of the
wants to do
challenges.
that. That's not a popular job.
Not a popular job.
I mean, people do it, obviously. We do have facilities.
We do have people who do it, yeah.
But it is
But
not, yeah, very few people, I would assume probably nobody dreams as a kid, like, yeah, I want to go sort garbage when I grow up.
I want to
That's
sort those recyclables, yeah.
that's what I want to do for my entire career, too. It's not just a summer job. I just want to stay here and, and do this. So, yeah, it's a whole...
I mean, and I think that's a great area of like, how do we innovate in that area? But then you have layers of government and processes, and
it's messy.
It is messy.
It's messy. Oh,
but we also, I know one of the other things is like we can't innovate our way out of the fact that we produce too much. You know, like we also need to tackle that. Like, how do we consume less, right? How do we do, like, there is also an element of that. Like, we don't want to stop some of our habits, but I'm like, we also need to like, how do we
maybe we should think about those habits too? Just a little bit. Just a little bit.
Yeah.
Overconsumption. That's one that, you know, like the fashion industry gets definitely, that's the most well-known, most populated, but I've talked to people about like fast furniture, and, you know, it's not just fashion gets all the headlines. It has the big numbers. It's kind of the flashy one to point at, but there's lots of industries where the same kind of mentality exists of, well, just make lots of stuff and throw away what doesn't get sold and keep going. And that's,
I mean,
that's an issue.
Food is an issue, right? I mean, 30%, I think that's the statistic, 30% of our food is wasted between loss in the supply chain, between consumer waste.
It's 30% before it gets to a store or restaurant.
I thought it was really. I thought it was only like 20%, and the last 10% was like the consumer.
Maybe they got some better numbers, but I was just talking to somebody about supply chain, and they were saying that it's about 30% gets lost, and it's all. It's not even from human error necessarily. It's stuff like equipment failure, refrigerator trucks go out. Like there's so much that happens between, it got collected from the field. And then there's steps between that and it goes to the store. Even farm to table has a few steps in between, and it doesn't all make it.
You mean they didn't go out and pick it and go to the table?
I mean, if you could do that, you can go to U-Pick place, but that is the only real farm. That's your only way.
Your strawberries, right?
Yeah, exactly. Well, this has been great. I really enjoyed talking with you about this. I think we covered so many great things. Hopefully everyone listening really learned at least one good thing. I think there's lots of things to choose from. As we wrap up here, I wanted to just open it up. Anything that we didn't talk about or anything in your head, you're like, I really need to say this before we wrap up. And then where to find you and connect with you and learn more about what you're doing.
All right. I think the one thing we didn't talk on too much was really just around being mindful around green claims. And if you want to use green claims, there's so many great certifications out there that are meaningful. So before putting we have a green product, green doesn't really mean anything. Sustainable doesn't mean anything without those certifications. So that's always and that's an area I do help companies like looking at their product. How could we find ways to do that? But that is also another, besides just like the misuse of the word plastic is another area that I'm like, okay, that's a cool claim, but what's your certification? Tell me why I should believe you. I think, and actually when you start building trust, but more and more, particularly millennials and zillennials, you're starting to see your customers are looking for those certifications. So that would just be one area also of like, there is nuance around that, but making appropriate claims that have that support. There's so many great, meaningful certifications out there. That would be only one open topic we didn't talk a lot about, but calling things plastic that aren't plastic is kind of the other one. But yeah, I am on LinkedIn, Joanna Pool. You can find me on LinkedIn there. My company is Sustainable Materials Consulting. I help companies with technical support around using sustainable materials, bringing products to market, and helping with credible green claims. Those are kind of the three areas I focus on, but also happy just to have a conversation and see how, if you're trying to navigate new materials, what does that look like for you? And yeah, was there anything else? I feel like I missed a question. No,
that was it. No,
right.
you covered it. You covered it. And for everyone listening, watching, there will be show notes. So check out those links. They'll be there for you guys. And Joanna, this has been a pleasure chatting with you. I think we could talk a long time about this. So maybe we'll do another episode. But
maybe
really
if there's interest, I'll let you know.
Amazing. Well, thanks for being on, Joanna. I appreciate it.
Thank you so much.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit petermanfirm.com or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.